Hey guys, this is Mrs. Lyons, and this video is going to cover how to calculate the energy that is required to convert ice, okay, so solid water, to steam. So in this particular example, we're going to convert 18 grams of ice at negative 20 degrees Celsius to 18 grams of steam at 110 degrees Celsius. Okay, now there are a whole bunch of constants that we need to use as we go through this process. Okay, the other thing that we need to do, and I think it's helpful, is to look at a heating curve as we do this calculation, okay, and kind of take note of where we're starting and where we're ending, okay. So our example says we're starting at minus 20 degrees Celsius. So if I'm looking at my heating curve, that means I'm starting here, okay. So if I were on my heating curve, this would be the point where I'm starting, okay, and I'm going to go from ice at minus 20. So leg one will be heating the ice. Leg two will be melting the solid ice to liquid ice. Step three will be converting ice liquid at 0 degrees Celsius to liquid at 100 degrees Celsius. Step four will be boiling, okay, so we'll be taking that 18 grams of liquid, boiling it to reach 18 grams of steam. And then finally, we want to go to 110 degrees. So we're going to just go a little bit farther. So leg five will be that little 10 degrees between 100 degree steam and 110 degree steam. Okay, so as we do this, we need a separate calculation for each step along the way. Okay, so step one is going from solid at minus 20 to solid at 0. So let's put that down here. So step one is going from solid ice at minus 20 to solid ice at 0 degrees Celsius. Okay, so to calculate the energy, so energy is going to be Q. Okay, it's going to be Q equals MC delta T. Okay, so M is equal to our mass. Okay, so that's going to be 18 grams all the way through our calculation. C depends on what state of matter we're in. Okay, so for this first leg, we've got solid ice. Okay, so solid ice, the specific heat of solid ice is 2.06 joules per gram degree Celsius. We will give you all of these constants when we require you to do a calculation. And then delta T is the change in temperature. So it's going to be the final temperature minus the initial temperature. Okay, so in this case, that's going to be the final temperature is 0. So 0 degrees Celsius minus negative 20 degrees Celsius. So our delta T is going to be 20. Okay, so I'm going to plug things into this formula to start. So Q is going to equal the mass, so 18 grams, times the specific heat of ice, 2.06 joules per gram degrees Celsius, times our delta T, which is 20 degrees Celsius. Okay, so if I plug this into my calculator, I'm going to get 18 times 2.06 times 20, 741.6. Okay, so Q for this first leg is 741.6 degrees Celsius, or excuse me, joules. Units for energy are always going to be joules. So I'm going to put a box around this because we're going to have to we've got all 5 steps on our graph that we've got to add together in the end. Okay, so step 2, let's look at our graph. What is step 2? Step 2 is going to be when we have a solid ice to start and we melt it so that at the end we have our total 18 grams is liquid water. Okay, now notice as we're going through here, there is no change in temperature. So we can't use the same formula. What we're going to use when we're melting is we're going to use Q is equal to M, which is mass, times delta H, and we call melting is referred to as fusion. Okay, so delta H of fusion. All right, so we're going to plug these things in again. So Q is going to equal, our mass is still 18 grams, okay, times the delta H of fusion, which is 334 joules per gram of water. All right, so let's plug this into the calculator. We get 18 times 334. That gives us, so Q of step 2 is 6,012 joules. Okay, so that's step 2. All right, what's step 3? Step 3 is going to be taking our 18 grams of water, liquid, at 0 degrees Celsius and heating it to 100 degrees Celsius. Okay, so this is going to be liquid at 0 degrees Celsius to liquid at 100 degrees Celsius. And I'm going to back up right here and put what we were doing in stage 2. In stage 2, we were melting the solid, all at 0 degrees Celsius. All right, so now for this, we can use the formula Q is equal to MC delta T, because we do have a change in temperature, okay? So let's just define these things over here again. So mass is still 18 grams. C, we need to use C of liquid water now. So it's got a different value. So C for liquid is 4.184 joules per gram degree Celsius. Okay, so, and then delta T is going to be T final, so we're ending at 100 degrees Celsius, minus T initial, so our delta T is 100 degrees Celsius. So let's plug this in. Q is equal to, the mass is still 18 grams, times 4.184 joules per gram degrees Celsius, times delta T, which is 100 degrees Celsius. So let's calculate this. 18 times 4.184 times 100, 7,000. So Q of step 3 is 7,531.2 joules. All right, so step 4. What's happening in step 4? We're taking that 18 grams of liquid and we're going to vaporize it or boil it until we get 18 grams of gas. So this step is 18 grams of liquid at 100 degrees to 18 grams of gas at 100 degrees. So again, there's no temperature change along that plateau. So we can't use Q equals MC delta T. We're going to use Q is equal to the delta H, the change in enthalpy of vaporization. Okay, so Q is equal to the mass times delta H of vaporization. Okay, vaporization being boiling. All right, so let's plug this in. Q is going to equal 18 grams times 2,260 joules per gram. Remember we said that it takes a lot more energy for water to boil than it does to melt. Well, here is the proof in the numbers. So we've got 18 times 2,260 is 40,680 joules. So that is significantly more than what we did in melting. Up here was only 6,000 joules. All right, so the last step. All right, remember we said step 5 is going to be this, just we're taking steam at 100 degrees and we're heating it to steam at 110 degrees. So let's see if we can fit this. We're going to go right here. Step 5 is steam at 100 degrees Celsius, and we want to convert that to steam at 110 degrees Celsius. Okay, so this time again, we've got a change in temperature, so we're going to equal Q equals M times C times delta T. Okay, now we're talking about steam. So the specific heat of steam is 2.02 joules per gram degree Celsius. So 18 grams times, we said that was 2.02 joules per gram degree Celsius. And then delta T is the final temperature of 110 degrees Celsius minus the initial temperature of 100 degrees Celsius. So our delta T, our change in temperature, is 10 degrees Celsius. All right, so let's plug this in. 18 times 2.02 times 10 is 300. So Q of that last leg is 363.6 joules. Okay, whew. Now we're almost done. Now we need to add up the 5 legs, the five segments. So I've got 741.6 joules plus 6,012 joules plus 7,531.2 joules plus 40,680 plus 363.6 joules. I'm going to add all of those together. So 741.6 plus 6,012 plus 7,531.2 plus 4,680 plus 363.6. So I get a total energy. Q is going to equal 55,328.4 joules. Now, that took a minute, right? So here's something I want you to look at. This was a long problem. This was a multi-step problem. It took us 5 steps, okay, to get from the beginning to the end. When you do this on a quiz or a test or a homework assignment, it's going to be really important for you to show your work. Okay, because if I tried to look at this and I didn't know what I was looking at, you didn't have the formulas written out, and you got the wrong answer, I wouldn't be able to tell where maybe you messed up. But as you might guess, there's a lot of partial credit to get along the way in this problem. Okay, so show your work every single step of the way. Okay, so that I can follow what you did and you can earn as many points as possible. even if you don't get the final answer completely right, it'd be really easy to transpose a number, or who knows, but show your work as you're going through. Okay? All right. Good job on that calculation. Have a great day. Take care of yourself.